Alright, so today I'm going to be talking about fireworks, and specifically the physics of fireworks, and the transfers of energy, which we've been studying. So fireworks have roughly four components, the first of which being the height. So you begin off with this cannon, which has the firework inside it, and when you have the gunpowder, which ignites, because all of the pressure that's created from that explosion can only go in one direction, it creates a ton of kinetic energy for the firework, which causes it to go in this big parabola that I've drawn. So once it gets to the top of its parabola, obviously, as we've learned, it has a ton of gravitational energy, and it's lost all of its kinetic energy to gravitational. And then, theoretically, once for a moment it hovers there entirely in gravitational energy and then transfers back into kinetic energy. But when you actually look at a firework, you only see half the parabola, right? Because it explodes at the very top. And that's because there's a fuse inside the actual firework that is timed so that it will burn out by the time it gets to the top. So when you're looking at them, it only looks like it's half following the laws of physics. But after the firework is exploded, then the pieces return and finish the parabola. So it does follow the laws of physics. It's just much more difficult to see because it's not all in one piece. So here's a little diagram of the actual anatomy of a firework. So inside it, you have the cap, and then all of these little dots, which are the stars. Those are little balls which light up when you heat them up a lot, and depending on their chemical compound, they'll have a different color inside it. Around them, you also have the burst charge, which is similar to gunpowder, or it is gunpowder, depending on the firework, which will cause your big explosion and cause the fireworks to go everywhere. And then you have the fuse, which ignites that. So this second burst here is really what everyone goes to see. So the first burst, the launch, is really just to get your firework up into a safe distance and so that it's impressive enough. And this is really what people are looking for. So you send all of these little stars. So the burst charge has the energy. It's all stored in chemical energy, and you have a little bit of heat just to spark that chemical change. And then it creates a lot of kinetic energy as well as a ton of thermal energy, as shown by the stars heating up to about 1,000 degrees, and a lot of sound energy because there's that second big boom that you hear in the explosion of the fireworks. So in terms of the actual energy transfers, you have the chemical energy that's stored in the gunpowder and the heat from the fuse. And that combination makes the kinetic energy, which launches it. The sound energy that you hear is that first big boom, and the heat. That heat ignites the second fuse, and the chemical energy that's stored in the burst charge, which causes all of the stars to go in different directions. Which is giving them kinetic energy. There's more sound energy, and there's also a ton of heat created in that reaction. That heat is what you really see due to the way that electrons lose energy. So when they gain a lot of energy from the heat, they lose it in the form of light. So that's what we see, and the chemical compound of that will change the light that we see, but we still receive it. And depending on the fireworks, occasionally it will have a bit of gunpowder in it, causing it to have a bit of kinetic energy as well. So those are the physics of fireworks with regards to the energy that they have. I hope you like the video, and you know a little bit more about fireworks now. Thank you.